Setting up Kubernetes cluster involves a lot of steps and also it is a time consuming process. How it will be if we convert this one into a script? Hey guys, welcome to Valaxy Technologies. My name is Ravi Shankar. In this video, we are going to see how to set up Kubernetes cluster on AWS, I mean to say EKS, by using Terraform script. For this, I have already written a Terraform script. I will walk you through with the step by step what and all it involves. Then we are going to execute that script. Let's jump in and see.
Hey guys, now let's see the steps which are involved to set up Kubernetes cluster on AWS, I mean to say EKS cluster by using Terraform. For this, we need to set up these things. That is, first we need to create a VPC, which we have already set up in our previous lecture. If you are watching this video directly, maybe you can check out our previous videos because it is continued to our previous videos. Next thing, create an extra subnet for Kubernetes. So far, we have created only one subnet. We are going to add one more subnet. Next, create an EC2 instance, which we have already created. Next, create a security group for Kubernetes. This we are going to do that one. And to set up Kubernetes cluster, we need to create all these things. That is IAM role, IAM policies, attach roles, then create EKS cluster and node group. Once this is done, I can say that our Kubernetes cluster is ready. Then we'll try to access our cluster. So with these steps, how our Terraform file looks like. Let's go and see that one. I have committed all the Terraform code over here. So in previous lecture, whatever we have covered, that is with V1 VPC with EC2, and the one which we are talking about now is that is V2 VPC with EKS. I have committed the information or required files over here. So this is same as our previous one, that is VPC with EC2 output and variables. Let me open this one and you can see here we are using variables and even outputs also, right? So this is the same as our previous one. Okay. Now let's go back, and as I said, we need to add one more subnet that I am going to add it over here. Next thing is security group we need for EKS. You can see here we are creating a EKS security group. Let me open this one, and there is a output file and variable file. Variable file helps us to change the values for the SG. This is the actual file. So let me see the variable what is there. So it is expecting a variable called VPC ID. So let's see how we are going to get it later. But if I go over here, it is going to create the security group under current VPC which we are going to create it. Okay. Next thing, we are going to see the outputs. It is going to just display the output of our security group. That's okay. And we are going to see the EKS. Okay, this is the one which you need to understand it. Again, EKS expects the variable file, that is security group IDs we need, subnet IDs we need, and VPC ID. So these three we need to give input to this SG. How to give this one to input, I will let you know. So next, go back to our EKS. And if you see the output, what is the output you are going to get? The endpoint of our EKS Kubernetes cluster. Okay. Next thing, we'll see the actual file. This is the EKS. As I said, we need to create an IAM role. So this is the IAM role and we are assuming a policy. Then we are going to attach the policies. You can see here all these policies are required. Then we are creating one more IAM role and here we are creating IAM policy. So like this, what and all dependencies are there? Those IAM roles and policies we are creating over here. Then we are creating a cluster over here. So cluster name is EDEKS01. This is the cluster name, and it is expecting a two subnets. You can see here subnet ID, where subnet ID 0, subnet ID 1. So nothing to change over here. We just need to change our VPC file. I will show you, and it depends upon this IAM roles. Nothing but if these IAM roles are getting created, then only it will able to create the cluster. Otherwise, it is going to fail. Next thing, we are going to create a node group. So node group name we are giving it as a dev, and backend is the Terraform local name. It is also expecting the subnet IDs, and you can see here capacity type. This is on demand, spot instances, and dedicated. You can specify whatever you wish, but we are going with the on demand. Next thing, disk size we need 20 GB, and instance type this is T2 small. Next thing, we are using the EC2 key pair. So this is the one which you need to change if you are updating it. According to your key pair, you can change it, or else you can give this one in the variable file. That would be easy. Okay, and desired we are mentioning 2, maximum 3, and minimum size is 1. Okay, maximum unavailable, 1 can be unavailable at any point of time. Again, it is creating a depends on these policies. Okay, this is what we are going to use it. Let's go and see how it looks like. So this is the one. I have already cloned it into our local system, but we need to change a little bit over here. As I said, it is expecting our EKS cluster is expecting 2 security groups, right? Sorry, subnets, right? But if you check our VPC, we have only one subnet. Okay, this is the only one subnet. I'm going to create one more subnet. So to create one more subnet, just we need to copy this one more time. Okay, and the first one I will name it as a subnet 1, and here also demo subnet 1, and the second one we are going to name it as a demo subnet 2. Even this one also, even here also subnet 2. Now we need to provide the CADR block for the subnet 2, right? So I will name the variable as a subnet 2. That is the reason in our previous lecture we mentioned it as a subnet 1. Now we'll go to variable file and we need to add the subnet for this one. So let me copy this one and I'm going to change it to subnet to CADR and I'm going to change it to 2. Okay, that's it. I can say that we have created one extra subnet. Even I need to save this file as well if I missed it, and I think it's fine now. Next thing is this is the actual file which we are going to execute. That is the reason we need to call our other modules. So this we call it as a module. So SG, EKS and EKS module we need to call from VPC with ec2.tf file. Okay, so to call that one we need to specify the module block type. Okay, so to define module block type we need to give the module, and our module name we can give SGS security groups. And here we need to provide the where is our module located. So our module is located in the /SGEKS. In the current location it is available. So SG underscore EKS. Okay, in the current location only it is available, right? If I go to my directory, so go to VPC2. So here in this file we are updating. So in this file where it can go, in the current location there is a SG underscore EKS file is there. So that is the meaning of this one. And if you do remember, okay, while checking our security group SGEKS, so SGEKS is expecting a VPC ID as a input. So we need to give the VPC ID for this one. So how we can give VPC ID? It is quite simple. So VPC underscore ID. Okay, this is the variable it is expecting. So this variable name we need to provide. So what is our VPC ID we are using? So this is the one we need to copy it over here. Okay, quite simple. So we are giving for this module, just give the VPC ID as a input. So now what will happen? This VPC ID will be defined in the variables file of our security group. Sorry, this variable file, not even this one. So under this one, yeah, here. So VPC ID, so it will copy. This is not required anyway. So this VPC ID will be replaced with the value which you are going to get it over here, so that it will be creating under same security group. Similar way, if you go to your EKS variables, it requires the SG IDs and subnet IDs and VPC ID. These three things we need to provide it. Let me remove this one. That is a default value. So these three things we need to provide it. Okay. So let me copy. Before copying, again I will go to my VPC with EC2. So here again I'm adding a module. Module name is EKS I'm going to give. And the next thing, source, where it is available, /EKS, right? This is where it is available. So what and all variables it is expecting. So not this one. Let me minimize the EKS and open the, sorry, let me open the EKS and variables. So it is looking for the SG IDs. So let's copy this one over here. So SG IDs, we need to give the SG IDs equal to our SG IDs are creating over here, right? So that is what you need to specify. That is module dot SGs dot security group public. Okay, so this is how we need to specify the SGIDs. So here we have created the SGIDs that we are calling over here. Whatever is created as part of the SGEKS, those security groups we are using over here. Next thing, it is also looking for the VPC ID, right? So same VPC ID we should provide. And the last thing, it is looking for the subnets. So go over here. So this is the one it is looking. So go over here and copy the subnet IDs equal to, we need to provide the subnets. So what are our subnet names? So that is what you need to specify over here. So let's go to our subnets. So this is the AWS subnet, demo subnet 2, right? Okay. So this is 2 and one more is 1. One thing we have missed, I will tell you what is that. So open the braces and just give the dot over here and dot ID. Okay, so this is how you can define it. So this is the one, and let me copy it one more time, comma this one. Okay, first one I can name it as a subnet 1 and the second one is subnet 2. So these names should be equal to how we have defined over here. Yeah, subnet 2 and here subnet 1. Okay, same naming convention we have used, so there is no problem. And one more thing, if you remember subnet 1, when we were creating, we have associated this one with the route table. Okay, that even we need to do for the subnet 2. That one step we have missed it, so we need to create one more subnet association over here. So subnet association, that is for demo subnet 2 ID. Route table is same. Route table is same. So even here it should be 1, right? We have given -1. Okay. So that is how you need to define. Let me save this file. And one more thing we missed it is we cannot give the same name for the both subnet association. So you need to give 1 over here and 2 over here. Let me save this file. Okay, that's it. I think we have done all the changes which are required. Let me check it one more time. That is and one thing we missed it, that is under which subnet we need to create our EC2 instance. Now there is no demo subnet, right? Either demo subnet 1 or 2. So I'm just changing it to demo subnet 1 and save it. Now let's try to execute it. Before executing, let me go to V2 and over here we have all the files. Now Terraform init. So we need to initialize it. Whenever there are new modules, we must initialize our Terraform scripts. Then Terraform validate. So we are just validating it. So there is a typo. Okay, so Terraform validate, and let's see the syntax. I think yes, it is good. Now Terraform plan. And by the way, I haven't removed our previous systems or VPC, so which we have created. On top of that one, we are adding this one. So you can see here, this is the VPC which we have created in our previous lecture. And this is the instance which is up and running. So now it should not delete this instance and it just create the Kubernetes cluster. Let's go now and execute the Terraform plan. Okay, it is creating 22 resources and destroy 3 resources. Maybe it is recreating the security group, right? So existing security group has been changed. That is what it is trying to do. That's okay. So Terraform apply. So let's apply it. It is going to take at least 10 to 15 minutes to create the cluster. We should wait till that time. So give S to create it. If we encounter any issue, we need to fix that and we should execute it again. Hopefully it should work. Okay, so it is giving conflict. Why? Because this is not properly removed before creating the new subnet. That could be the issue, I'm assuming. So the thing what we can do is we just need to change the CIDR block of the subnet 2 to something else. So let's go over here, variables. So let me change it to 3 over here. So subnet 1 will be under 3 and subnet 2 will be in the 2 range. Okay. Now let me save this file so that it won't create any conflict. Let's apply it again. So whatever resources has been created so far, those resources remain same, and it is going to update the new one. Okay, just give S. Earlier it was 28, now it is 23, now it is 5 only. Let's see now, because it should destroy our EC2 instance, because earlier it was in 10.10.1 series. Now it is going to change it to 10.10.3 series. Again, we are getting the subnet related issues. So we need to make sure that these two are creating in the different availability zones. So yeah, I think we are using availability zone as well, right? So this variable, it is using the same. So subnet 1, which availability zone we are using? That is AP South 1A. So subnet 2, we can just copy it, and we will name it as a subnet 2 AZ, and let me make it as a 1B and save this file. Subnet 2, right? So this is subnet 2 minus 2 over here. So subnet 1, let it be as it is. So now subnet 2 is getting created under 1B availability zone. Okay, I'm just trying to fix the errors on fly so that you can understand it better. So what it is saying? Okay, there is no closing braces, it is saying. So let me go to variables, and I just need to close it out. Okay, now let's try it out again. Yes, to create, this time only 4 resources, among them 2 are going to get destroyed. Quickly, let's see what's happening in our AWS account at this moment. So this is my EC2 and VPC. Let me go and check out for the this is the VPC we have created, and subnets. It should create subnet 1 and subnet 2. A route table. Yep, it created a route table, and if I check for the subnet associations, we could see 2 subnet associations are there. Okay, let's wait for a while to get it completed. So it is saying that it has created a cluster. Let's go and check it out. So EKS, let me open in the new window. Yes, you can see here a new EKS has been created, and you can see here 1.25. This is the Kubernetes version which it is using. And while communicating with this cluster, we must be having a client version below to this one. Okay, I will tell you how to connect with this cluster by using Linux system. So we'll wait. I think there is some issue. It is saying error while creating EKS node group, unexpected state. So it is saying that assign public IP address to the instance while launching into it. Okay, one thing we need to change. We need to enable auto assign public IP to the subnet. Okay, that we didn't do. So if I go to this one, so we are assigning the public IP over here, but we need to give the auto assign the public IP to the subnet actually. Okay, so let's enable that one. So we are facing a lot of issues, but that's okay. It is for learning purpose. So I will just remove this one, or let it be. And again, why I should need to touch that one. In this one, I'm going to map it as a map public IP on launch. That's true. That is the thing we need to specify even over here. Okay, this will helps to create the public IPs on launch. Okay, let's try it out once again. Again, it removes the subnets and recreate the subnets, hopefully. Let's see. It is destroying only one resource and 2 change. This could be subnets. Okay. Yes, to queue. So it is destroying node group and recreating. Let's see on the console. We could able to see 2 EC2 instances are getting created because the node group is getting ready. Yes, 2 instances. Those are T2 small. So let me see, this is 10.10.2, this is another subnet 10.10.3, even this is 10.10.3. Okay, good. So these two are in 1A and this is 1B. Let's see. Okay, so it has been successfully completed, and we got all the resources. Now how we can able to communicate with this cluster? So that is where we need kubectl we should install. So now all these all are in same VPC. So I can connect from this system to remaining 2 systems. This system nothing but this is demo server, and even if you are not sure, you can get that IP from here. So 65.2.170.128. Okay. So that is the one, right? Not this one then. Yep, this is the one. So this one is the demo server. Let me take this server and connect to the system. Mobile extern session, and I'm trying to connect to the cluster. Okay, so I'm just logging into the demo server. Now let's log into a root. And the next thing is we need to install the kubectl. At this moment, if you check for kubectl, it doesn't work. Okay, now we should install kubectl versions for Linux. If you go and we need to install lesser than 1.25. okay, that's what I was saying. So this is the actual URL. You can find it by searching the similar way how I have searched, that is kubectl version for Linux. So go to Amazon official page and you can download 1.25, 1.24, 2.3. So I'm going with the 2.3. So let me copy this one and you can just clone it. So now we have cloned and it has been downloaded. We just need to give the execution permission to this. So I have given, then move this one to the /usr local bin. Okay, now let me execute kubectl get all. Of course it is going to give you an error because it cannot able to connect with the AWS cloud until unless you give the role, or else you need to run the AWS configure. Okay, so I'm going to run the AWS configure. Here I need to give the access key ID, secret access key, and region name. Region name I'm giving AP South 1 and enter. That's it. So I can create a role and attach to this system, or else I can give the credentials of my user. So that you can find it in your local system. That is go to this PC and users. So in Valaxy we have .aws, right? So go .aws. This is where you have credentials. So this is a sensitive information. That's the reason I don't show you. So I will just give these credentials in the off the screen. Okay, now you can see here I have provided the access key ID and secret access key so that I can able to configure the AWS credentials. So now let's enter and kubectl get all. Okay, now I am trying to communicate with my cluster and still I could see that okay, it is giving some connection refused. Why? Because you need to get the credentials of your Kubernetes cluster. So how to get the Kubernetes cluster? That is where AWS EKS command comes into the picture. I will grab the command and will execute it. So this is the command AWS EKS update config and region AP South 1 and name our cluster name. Okay, if your region is changing and cluster name is changing, according to that you need to update it. Now you can see here it stored the credentials or certificate to connect with our cluster under /root.kube.config. Now let's execute the same command kubectl get all, which is going to get the Kubernetes service, and kubectl get nodes. If you check, you can see the 2 nodes over here. Okay, so this is how we can set up our Kubernetes cluster by using Terraform. Anyway, for you it could be simple because I have already updated everything. You just need to use the same code, but only thing what you need to change is under EKS. Okay, so here you need to change the key pair name. Okay, that is the only change. Otherwise you can use the same script as it is for your purpose, and if you want to change the instance type, you can change it. Alright, that's all for this video, and thank you so much for watching this video. If you like this video, please give a thumbs up and let me know if you want to see how the deployments will happen through the Helm charts and how we can configure Prometheus and Grafana. Based on your feedback, I will create the further videos on this one. Thank you so much and see you in another interesting video.